Hello, welcome to our session. Today's topic is clear skies, troubleshooting and planning your current and future sky deployment. Our next session is hit your RPOs every time with Actifio's advanced SLA features, and that is on March 28th, 1 week from today. Today's presenter is David Fowler. He's the manager of global enablement. And like I said, he'll be taking you through the lesson today. I'll be sitting here in the background managing the question queue, managing the resources. With that, once again, want to introduce David Fowler.
Thank you, Paul. And thanks everybody for joining us today for our Clear Skies, Troubleshooting and Planning Your Sky Installation and Deployment. Today we're going to go over about every aspect of the installation, site assessment, post-install assessment, VMware assessment, really all the steps that you would want to take to self-install Sky on your own without the need for any Actifio professional services, and do it in a way that you can immediately go into production and be successful. We'll cover some environmental variables, we will cover some testing, and some precautions and things you're going to want to keep in mind before you actually start the deployment. Now, before I get too deep into the content of this webinar, I will say that if you've never deployed an Actifio product before, specifically our Sky appliance, I would urge you to head over to our YouTube channel, and that link is at the end of this presentation. You will get a copy of it, and take a look at our capacity planning webinar. This will walk you through vDisk and mDisk configuration, how to actually build your pools, considerations when you're using multiple controllers, multiple RAID sets, multiple sockets. So without any more delay, we will get into our Clear Skies, deploying and troubleshooting your Sky installation. So today we're going to start off with some site assessment. Now, that is to say, are we going to install Sky in the right place? So as anybody who has used a Sky will know, depending on the capacity of the Sky appliance, we do have different hardware, or what we'll say virtual hardware requirements. Now, as you can see, they are fairly light until you start to get up into the larger pools over 30 terabytes. And you will note, if you do need encryption, we do require extra cores to support that encryption. Now, to get started, what I'm going to suggest is that you actually make a VM. I like Debian, use whatever you like. And we're going to set it up in the same ESX, same vSphere, using the same data store that our Sky appliance would use. Now, when we set it up, we're going to set our reservations and our resources in the same fashion we would if we were deploying Sky itself. Now, these upfront steps are to give us a good idea of whether or not we're going to be putting Sky in the right place. Maybe this isn't the right ESX host. Perhaps there's too many other VMs occupying the LUN that this ESX host talks to. Now, of course, that will hurt performance, and we can figure all of this stuff out ahead of time before we're actually trying to go into production by doing some of these preliminary tests. Now, you really only need to do this once. So if you were going to install 7 Skies, you could really just make this VM, clone it, and then push it around to the different environments you want to assess to see if they're suitable candidates for the installation of a Sky appliance. Now, as I said, I would advise installing a test VM. I like Debian. You can use what you like. If you are a Windows person, maybe OS2 Warp, whatever OS works best for you is absolutely fine. Now, the configuration we're going to be doing is not actually at the VM host level. It's going to be underneath at the ESX level. We're actually going to be configuring the VM container to make sure that it's as close as Sky as we can get, so we can really get a good look at this environment and make sure that we're installing in the right place. So the Sky appliance do need to have CPU and memory reserved for that VM. We also want ballooning to be disabled. Now, all of the reasons that VMware will tell you that ballooning is great and that we want it are actually all the reasons that we do not want it in Sky. We don't want dynamic provisioning of resources. We don't want other VMs saying, hey, Sky's only using 20% of its memory. Let's go ahead and take some of that for this other VM that's really busy. What ends up happening is you end up with a request to perform a workload on Sky, and that balloon filter will have taken your resources and allocated them to another VM, leaving the Sky unable to perform as we tell you it will. So the next step is going to be to create 3 disks. And now these disks are going to represent your pools. And at this point, we can either do some test disks, and I'll describe the minimum sizes for a test, or we can actually make the disks that we would be using for the pools for the Sky appliance. If you have the ability to do this, this is what I recommend. This will allow us to get a really good look at that LUN performance. And once we've done the testing that I'm going to describe shortly, we know fairly well that these pools that we've created are on the right storage, the right network configuration to work well. Now, if you don't have the ability to put in the full-size pools, some test pools will work fine. That will still allow us to look at things like the traffic path, the availability of the controller, and we can still run some of our network and disk performance testing. So if we are going to do just the minimum, just to do some testing, we need 400 gigabytes for the primary pool. Now, the primary pool is where the Actifio software lives. You're never actually going to store any data there. Now, the snapshot pool needs to be a 10 gig minimum, and dedupe needs to be 1 terabyte minimum. And once you've got those disks set up, we can actually start looking at site assessment. Now, I did put some quick steps in here because the reservations of resources are incredibly important. I have looked at more than a couple Sky instances where they were underperforming, and the first thing I check is the reservations. And when I see reservations aren't set, we can then start digging into the VMware logs and we can say, okay, well, this should have 62 gigs of RAM, but the balloon filter has pulled 50 gigs of that away to another VM, hence the underperformance. So this is a screenshot of your actual ESX console. It looks very similar in the web view as well. Now, obviously, we need the machine powered off. In a lot of these regards, Sky acts just like a regular VM. If we want to start changing things around, we really need to shut it down first, so that when we bring it back up, the config file for that VM is reread and the proper resources are allocated. In here quickly, we go over reserving CPU. Now, a quick tip here, when you are reserving your CPU, your virtual processors, if you have the ability to do so, I would recommend assigning it cores from different physical sockets. Now, why would we spread it out? Well, really what it comes down to is bus lanes. So if we have 8 cars and we're trying to get those 8 cars down the highway and we have a 4-lane highway, then we end up with 2 rows of cars, 4 cars wide. And that represents the workload going from the VM to a single socket hosting all cores. If we spread those cores out, say we've got a dual or quad socket node, and we're talking physical hardware, if we distribute those cores across all 4 of those sockets, now instead of 2 rows of 4 cars waiting in queue, we now have 4 rows of 2 cars and nobody's waiting, and we actually have enough room to move other traffic because we've still got 2 more lanes open. So if you are able, split those cores out among physical sockets. And of course, each core should have 2 gigahertz minimum, and I'll emphasize minimum. You can always put in a little bit more. If you want to get the numbers that we tell you that you'll get, it really has to be 2 gigahertz, and it really has to be reserved. Now, disabling ballooning, these instructions are actually not that easy to find because all of the best practices in VMware say that you should enable the balloon filter. But for some of the reasons I mentioned earlier, we don't want this Sky appliance to have its resources taken and given to another VM. So we are going to disable the balloon filter here. Again, we need to make sure that the VM is off. And then from there, real quick, right click, go into settings, and under the advanced tab, you can see here under configuration parameters, there is one manual step, and I'm going to show it to you. When you click that, you're going to get this window open here. This schedmem max mem control line will not exist in your config. You're going to need to click add row, as I've noted here with the arrow, and you'll see in orange, that is the line that you're going to want to add to the configuration parameters. This can be scripted. You can do it via the VMware API. I'm not really going to get into some of the VMware CLI stuff today. We'd be here for about 3 hours, and I'll try to get you out of here in about 60 minutes. So you can also do this on the host. Again, that's kind of a use case specific thing. Windows, you can go in and you can tell it, if this machine is virtualized, don't allow any ballooning against the resources. But really, this is the most accessible way to do it. And again, VMware's got a wonderful knowledge base, and they've actually got some templates that you could use to script the addition of this property to a certain list of VMs. So if you're going to do this at the host level and you had 100 hosts that you needed to add this to, VMware does provide some automation to run this in the background in a script. Okay, so why do we need all of these reservations? All right, so for memory, dedupe is going to try to claim a certain percentage of the memory made available to it. If there's no reservation, it's going to actually start to try to page cache into dirty page files. Now those are page files on disk. We really want to force that cache to stay in memory because as soon as we start writing to disk, we slow down and we're so transactionally active. I'm talking 5 figures, 10,000 transactions a minute, and that's pretty calm. It can go much, much higher than that. If you just have to start making all those reads and writes from disk instead of memory registers, you're going to notice a huge hit in performance. Now, dedupe also will determine how much page caching can be done by querying the VMware API to say, how much memory do I have reserved? And just some round numbers. Let's say, okay, Sky, you have 10 gigs of memory. Dedupe looks at it and says, okay, I'm gonna need 3 of those. So the rest of the machine can contend for who gets the last 7. Well, if we don't give it a bounded limit, like I said, then we start writing into disk, and we don't want to write to disk. We want to stay in memory. And the way that works out is, as you can see, the bottom bullet under memory, swap file equals configured memory minus memory reservation. So if you have a VM, Sky VM, configured for 16 gigs of memory, but you've only reserved 8 gigs of memory on boot, that VM will create an 8 gigabyte swap file on disk. And again, for the highly transactional nature of things like deduplication, we don't ever want to write to disk until we're done. We want to do all of our work in memory. And then once we've finalized the deduplication job, then we write it to disk. Next is CPU to bus optimization. That's the analogy I provided about the cars going down the highway. You can only fit 4 cars across the highway in a 4-lane highway. Splitting up, reserving those cores and splitting them among physical sockets essentially allows you to be the traffic cop and only send a couple cars down each road, making sure you don't hit any congestion. Now, this will also prevent queuing of IO requests, which again, we're very highly transactional. A little bit of queuing is okay. We don't want to see kind of chronic queuing or extended queues though. And dividing up your traffic across all these bus lanes helps prevent that. Now, this also makes sure that the dedupe engine has enough horsepower to deliver the throughput that you need. Now, if you're expecting 7 terabytes of dedupe ingest and processing a day, but you only give us 1.5 gigahertz of processor, you may be short a core and you don't reserve anything, I'm going to predict your throughput is going to be closer to 1.5 to maybe 3 terabytes a day. So all of these reservations, if you want to make the performance metrics that we talk about, these reservations are really essential. The balloon filter, we've kind of covered that briefly already. This is going to prevent resources from being pulled away from Sky and sent to other VMs. If we write to a memory register, but then we let it go inactive because we're just letting it sit there as a cache file, this will prevent VMware from pulling those memory registers out from underneath us and causing us to essentially restart the job. And then, of course, it just ensures that we've got the throughput that we need to do the workload that we tell you that we can do. Okay, so we've got our test VM set up, our Windows, or in my case, a Debian VM. There's a bunch of tools that we can use at this point. We've got disk attached, we've got our reservations in place, we've got everything built. All we're really missing is the Sky software. But what we need to do first is let's make sure that we're going to install Sky in the right place using the right storage. So there's a ton of tools, and the reason I choose Debian is because I feel like Linux really has the best system monitoring tools. If you happen to be a PowerShell guru and you know of much, much better ways to do it in PowerShell, please go ahead and use PowerShell. It doesn't have to be Linux. It just needs to be a means to an end, and that end is being able to, with some accountability, verify that we're going to be putting Sky into the right place. Now, over here on the right, I've included 2 of my favorite commands, and those are the SAR commands. It's System Analytics or sysstat commands. Very easy to yum or apt-get these packages down. And there is an equivalent on PowerShell as well. It's not quite as robust, but it does exist. Now, We're going to run these from our test VM before we ever install Sky to make sure that our container, our VM container, is in the right place and has good pathing to storage, and we're going to see good performance metrics. So the first command we're going to run is going to be sar-b, and then we're going to follow with the sar-d. These are very well documented commands. I don't want to read the man page aloud to you, but just two of the most important metrics that come as output of those are highlighted here. Now for sar-b, your await and your service time, that, people debate the validity of await. So if we are looking at your average wait and we're seeing a discrepancy of a couple of milliseconds, I would kind of discount that. Await can, however, tell us if we've got something big wrong. So if we see a request go to the disk and we see the await returns a value of 300 milliseconds, that means that we were waiting for 300 milliseconds on storage. And as I mentioned before, when we're talking about 10,000 transactions per minute multiplied by 300 milliseconds wait per transaction, you can see how that can add up and certainly hurt performance. Now under sar-d, this is going to be more network-based than storage-based. Again, it gives a ton of output. I've just kind of highlighted the two that I generally look at first, and that's the average queue size. We talked a little bit earlier about process queuing and bus lanes and whatnot. This is going to be similar, but instead of going to the kernel or the socket, this is actually going to be going to the storage. Now, a little bit of queuing is okay. We can see the average queue dash size, and a little bit's fine. However, if we run this command and we see the average queue climbing and climbing and climbing and never really relieving, that tells us pretty definitively that we've got network congestion. Now, the percent utilized, that's going to be how much CPU time was being used at the time that the request was made. Maybe we set a CPU, but we forgot to set the reservation. Very easy mistake to make. We could find that here in the utilization going to 100%, showing absolute saturation of the virtual processor that's been assigned. Now, where these are system tools, they're not Actifio specific. They're not going to give you an error code that you could reference in our knowledge base. But at this point, we're still very much just dealing with a VM, nothing Actifio specific at all. So all of your sysadmin, DevOps, network administrator skills are still all fully in play here. We're just treating it as a VM at this point. Another two that I do like is IOTop and iPerf. Generally, if I get output that I'm not happy with or that I'm not convinced by when I run sar-b or sar-d, I'll then follow in with IOTop and iPerf. As some of our sysadmins joining us today will know, it's not always a single error that tells you what's going on. It's kind of a collection or aggregation of facts that you get from these different tools, and you put them together and make an educated decision about what you're seeing in your environment. Once we get to the actual Sky appliance itself, we are going to get some very specific errors that are referenceable and very easy to just kind of address and take care of. However, at this point, while we're qualifying the environment, you really just rely on your Linux or Windows PowerShell skills to go in there and query the environment to make sure that we're setting it up right, and to then understand and chase down any issues that we may find. Now, if you are chasing down these issues and you're getting ready to install Sky, you're an Actifio customer, and you've just run into a dead end, you're beyond your area of expertise, or you're just stuck for whatever reason. That's why we've got our maintenance and support contract. Gather all the information you've gotten so far, open a case with our support team. If you don't have the information, that's okay, but that means they're going to then need to go in and run all these tests themselves. So to speed resolution, if you just document all this stuff while you are kind of working through the process, if you do hit a problem, you can include that documentation in your support ticket, and that'll help us get it resolved much, much faster. Now over on the left, I've got some external tools. I don't cover all of them. I just wanted to kind of show that there are a lot of tools that we can use for this purpose. The one that I'm going to kind of champion today is going to be VMware IO Analyzer. It's a fine tool. It will do everything that we need to do for this. If you are a VMware customer, it is free. You can just go download it. It's yours to take, which is the big reason for my kind of getting behind this one, is a zero cost solution that ticks all the boxes tends to be the right solution. However, if you have a preference, if you have SolarWinds, ServiceNow, Manage Engine, any of these other VMware monitoring suites, they also have the tools. No need to install an additional tool if you've already got SolarWinds running in your environment. You could just leverage SolarWinds to kind of give you some performance metrics on the Sky or on the VM that will be hosting Sky soon. And here's just a quick look at the IO Analyzer UI in case you've not seen it before. Again, if you have a tool that you like, please use what you like. I just offer these things up for folks who maybe haven't had to do this before and are really just starting to kind of research this project and need a good starting place. So as you can see, we do total IO per second. We do read and write times, CPU utilization, all the things that I just talked about, you can actually pull out using the free IO Analyzer tool from VMware. Okay, so we've run all of our tests. We've got our trusty test VM all built. We've got our reservations in place. We took a look at some of the SAR outputs. We made sure we've got good reservations on everything. And maybe we didn't get the numbers that we wanted to see. So here are some of the points that we would check to start to identify and troubleshoot storage latency issues. Now, again, I'm going to reference SAR-B, SAR-Bravo again. This is a great command. The output can be a little overwhelming if you've not used it before. In my opinion, it is worth kind of sticking in there and learning this command because it is so useful. And it's available with some very few Unix exceptions. It's available across the board on any Linux distro that you're going to want to use. So we've got our VM, our storage isn't working great. Maybe you're not familiar with SAR, and the output maybe just isn't making a whole lot of sense to you. So we just want to try some stuff to see if we can find some improvement. So the first thing we're going to do is we're going to vMotion and storage vMotion that VM and the disks created for it to a new storage location. Maybe that storage is just too busy. Maybe there's some routing, and although that piece of storage is 12 feet away in the data center, for some reason, there's 27 hops on the network to get there. We can start to rule some of this stuff out real quickly by just putting it someplace that you know works well. The next thing we're going to do is we're going to look at how many VMs are actually using that LUN. So if we've got this gigantic LUN and we've got 50 VMs using it, we have to think about all of the requests that are being made by those VMs down to the storage controller. Again, I'm going to mention how transactional the Actifio is. If we're making 10,000 requests and we've got 15 other VMs, and let's say those are highly transactional too. We'll say those are SQL databases or Oracle databases. You're going to find that average queue size that I mentioned a couple slides ago, you're going to see that go up and up and up and up. And these aren't requests for a huge amount of work to be done. They're actually very small workloads. However, it's just the sheer quantity of requests that are being made, one request per transaction, that we can actually bring that socket, that physical socket that has been assigned to all these VMs, we can bring it to 100% utilization and keep it there, and the queue will just grow and grow and grow. Now, in that case, these are pretty easy to identify. The quick resolution is to either create a new data store or just start paring down some of the other VMs that are using that data store. Now we can also look at the host. The host will tell us some information regarding how the host is interacting with the storage. And this is one of the reasons I suggest creating a test VM here, is because you're gonna want a kernel that can interpret all of this and then give you a human readable message. So as you can see here in orange, you'll actually see your network devices, and you'll see this in Windows Event Log as well. You'll see your network devices time out. So we've made a request to the storage. We waited 500 milliseconds, didn't answer. We made an assumption, and when I say we, I'm talking about the Debian VM at this point, that storage is not online. And so we'll kill the operation and let you know, hey, I tried to connect on this iSCSI path. It timed out, the storage did not talk back to me in the pre-configured interval, which is generally around 500 milliseconds. That is a bright red beacon to let you know that this storage is overconsumed and not a good candidate to host this Sky appliance. Now, once you've got everything set up, the IO Analyzer that I mentioned 2 slides ago will actually do a pressure test. So you can look and you can determine what the maximum IO you could possibly get is. Now, this is not going to be a one-to-one test that exactly duplicates what a Sky appliance would do, we actually have our own tool, which we can use for you on the environment that you choose, that does a one-to-one replication of what storage and network traffic looks like on the dedupe side of our system. So if you are running all these tests and you're close, but you're kind of on the line, I would give us a call and say, hey, I need you to come in here with your, and everybody's familiar with iPerf. Our in-house version that replicates dedupe is called IOPerf. So if you're kind of right on the line, not sure if you are in a good place or a bad, but you're really close, go ahead and get in touch with us. Let us know that you need your environment analyzed and just kind of scope to see if it was a good candidate for Sky installation. And then we can run our proprietary tool for you and let you know exactly what our output is. Now, we are going to be making that tool available to you. It's not available today at the time that I'm recording this. However, before the end of the quarter, this proprietary IOPerf tool that replicates dedupe should be available to every Actifio customer. A couple last steps, and some of these we'll just, I don't want to call it common sense, we'll call it good sense. Take that IO meter performance analyzer and run it on a physical machine on that same network branch using the same storage. See if you get different results. If you do, that tells you everything you need to know. Also take a look at your iSCSI configuration for reservation conflicts. Just to give you the most ridiculous example I've seen at Actifio, I have seen a Sky installed on an iSCSI branch. That iSCSI branch also hosted the VoIP phone system. And we were trying to figure out some troubleshooting issues. We didn't know that we were on the same iSCSI branch as VoIP. And then the phone rang and I lost connection to the Sky. And that was my first clue, is something weird is going on here. And so I was able to then call into that VoIP system. And every time I rang the phone, I could disconnect Sky. So just make sure that we're in the right space as far as the iSCSI deployment. Make sure there isn't some QoS that's going to point resources someplace else. As much as we want all those reservations at the VM level, we really want the network to be as clean as possible as well. You don't need to isolate us. However, the less traffic you can pass through that switch at the same time you're trying to pass it to us, the better. The key here is do not put us next to something that's QoS'd away from us. Now, if you are using multipathing, I'll pick on PowerPath a little bit here. Some of the default settings do not work well with us. One of the default settings in PowerPath is that if PowerPath cannot see an open path to the target, it will queue your IO. Now, what that means is it just ties up that one path and it waits for it to come open again. If that path is reserved and something else is using it, your job will never make it to the Sky and you will never see an error. The reason you will never see an error is because the behavior dictated by the PowerPath configuration is that we are to queue and hold station until that path becomes open. And that's exactly what we're doing. So your jobs aren't running and nobody's reporting a failure. Take a look at your multipath configuration. Now, just in case somebody here is using PowerPath, the correct configuration is fail if no path. If that path is tied up, we'll look for whatever other paths are described in the multipath, and then we'll use that path to move your data. And again, document everything. As you're kind of doing your site assessment, doing your LUN testing, making sure that you're in the right VLAN, there's no QoS, write down everything. If you get stuck, if you need help, we'll be able to use those notes. And rather than having to go in and kind of start the investigation to look at all the testing you just did, we'll be able to pick up right from where you left off and move forward with you. And that should drive the resolution time way down and get you running pretty quickly. So next we'll talk about network latency. Again, a lot of this is just good sense. It's not Actifio specific. So a lot of these things are probably already in your sysadmin toolbox. We can use iPerf and we can use the IO analyzer tool I mentioned earlier to check the actual maximum bandwidth. We're just going to flood that pipe and see how much traffic it can sustain over a period of time that you specify. If you have the availability, I would run it for about 10 minutes. You can also run iPerf of the IO analyzer tool to a machine outside the ESX host. So we've got a physical SQL box sitting next to an ESX node, and that ESX node also hosts SQL. Let's run it on both and compare the results. If they're on the same switch, same VLAN, same network, same storage, but we're seeing hugely different results between the physical host and the virtual host, then we're going to want to dive back in and take a look at that VM configuration again. Generally, it turns out that something like, you turned the bloom filter off, you went to save it, VMware said, hey, you sure you want to turn that off? It's a really good idea to keep it on. And then you clicked OK just to get out of the window. And what you didn't see was you actually just turned the bloom filter back on. So next we're going to take a look at, and again, this is just good sense network troubleshooting. Take a look at another VM that sits right next to the one that we're trying to get at. And this will let us know if the VM is not configured right. And if you are getting the same results, we can rule out something like a bad CPU, a bad vSwitch, a bad IF bridge, all those kind of, we'll say behind the scenes or under the covers things that VMware does that many of us are familiar with, but if you don't have like a VMware certified professional certification, some of the minutia behind the vSwitch and the IF bridge, the rabbit hole goes pretty deep there. So we can run some of these tests at a high level and just kind of get a good idea of whether or not that component is configured correctly and ready to use. And again, document everything. Now, before we actually begin the installation, the first thing we're going to do, and I'm going to actually spend about the next 10 minutes describing to you how to install Sky. And it's a little bit ironic because I'm going to spend 10 minutes telling you about it. The truth is it only takes about 5 minutes to do. So we'll get started. The first thing we're going to do is we're going to remove that test VM, that Windows or Debian VM that we're using to run iPerf and SAR, everything we're using to evaluate our environment, that's going to go. We're going to take note of the data stores. If we want to reuse, if we've made the pools that we're going to try to use for our production Sky instance, we want to make note of the data stores we used, the iSCSI initiators we used, the LUNs we used. We just did all this testing on these components. So obviously, if we got good numbers, we want to reuse them. So make note, and you could just go right into the VMX config in the VM, and you can copy that file out, and that will tell you everything that you had configured. Generally, just pen and paper, make a quick note of how you set things up. But if you're really looking for kind of an exhaustive configuration, maybe you want to save it so that you can use this test VM later to qualify other environments for Sky. I would just grab the VMX config. That way you could just deploy from that if you needed to. Alternatively, just clone the VM that you use to test it, and you could vMotion it to whatever new environment you needed to assess. Now, we're also going to note the disks that we created for the pools. We can either reuse disks if we were able to set up our production level disks, or we can or if we just went test size, that 400 gig primary, 10 gig snap, 1 terabyte dedupe, we're going to want to note where we set those up so that when we go to do the install and we go for the full, maybe 50 terabyte dedupe pool, 30 terabyte snap, we know exactly where we stood it up. We know what the metrics were to that controller and that disk, and we can basically just take this tiny VM that we've been doing all of our testing with, drop Sky on top of it, grow those pools out, and we should get, obviously the results are going to be a little bit different, but they should be very, very similar. We shouldn't hit any issues if we do it like this. And then to get started, we're going to copy the installation OVA. So that's going to be Sky 8.1, Sky 8.0.1, what have you, .OVA. We're going to copy it over, and we're going to deploy the Sky appliance from the OVF. As you can see here, we'll go to File, Deploy OVF. We will select the OVF here. You can see the path where I've got it stored. Now you will immediately see 130 gigabyte drive get created. Now this is not part of the primary pool, the snap pool, or the dedupe pool. This is the boot drive for the VM itself. You do not need to create this disk, and you should not ever manage this disk. The deployment of the OVA will actually create this disk, get the boot drive set up, and it will just take care of all of this for you. Because we are dealing with kind of the notions of disks as pools, whenever we're talking about disk use, I just want to give you a detailed explanation of what each one does. I don't want you to boot it up and say, wait, I should only have 3 pools and I see 4. What's going on? There's an extra disk. That extra 130 gigabyte disk that you see is just the boot drive for the Sky appliance itself. And once that's laid down, we're going to give it a name. Any name that VMware will take is absolutely fine. We'll select our ESX server. Now, this is very important for the creation of the disks. The disks need to be thick provision, eager zeroed. Again, thick provision, eager zero. I know with your hosts, a lot of times that we tell you to save on MDL to use thin provisioning. Well, again, for all the reasons we say thin provisioning is great for hosts, those are all the same reasons that thin provisioning is terrible for a Sky appliance. We don't ever want those disks to be moved or changed or put into a share or accessible by anybody else. This is production data service. We need to be isolated. You don't want a random user to start writing their PowerPoint data into your dedupe pool. The absolute last thing you want. So just, yeah, make sure they're thick provision, eager 0. That will make sure that they don't grow. It also helps keep them isolated. After this, we're going to add IPs. Now, we're still on the ESX server, still in vSphere. So we're going to add our IPs here, which will be auto-populated in the installer later. Now, it'll take a minute for the OVA to finish deployment. Depends on your system, generally 2, 3, 4, 5 minutes. Once it's done, you will see Sky show up in your inventory on that left-hand pane. You can see it right here at the end of the arrow. Now we're going to select that Sky, and it'll be obviously whatever name you named it. And we're going to select Edit Settings. And this is where we're going to do all of our stuff like setting CPU memory reservations, disabling the balloon filter, setting up our iSCSI initiators, everything, all the magic happens right here. So again, I just kind of reiterate that there will be 4 total disks. You're going to create 3 disks that are going to be pools, and then you get +1 disk at the end. That's the boot drive for your Sky appliance. Now you're going to want to go in and check out this pane here, the left-hand pane under the virtual machine properties, to make sure that those disks were added. If for some reason you speed along and not all 3 of them get in there, it's okay. We can come back and we can fix it. But generally, as you can see in the screenshot here, it says new hard disk adding. Wait until those complete and then continue. As a matter of fact, I don't think you will be able to continue until they do complete, because the next step is to actually power on the VM. So we're going to right-click power, and we will power on Sky. Generally, what I'll do after I power on Sky is I'll send a ping to it, and then about a minute, 30 seconds to a minute, after it starts returning ping, all the web services are up, and we can now access the Sky appliance via browser. Now here's a snippet of the installation UI. Now, as I mentioned, the IP that you gave to ESX, we'll run a quick API query. We'll say, hey, what's the IP here? And we'll pre-populate as much of this for you as we can. However, you are going to need to give it a new name, because you'll have your VM name, Sky 8.1 or what have you. But you're also going to need to give it another appliance name. So, Sky Prod, Sky DR, Sky Test and Dev. It can be the same name that you gave it in vSphere, but you do need to name it twice. We need 2 distinct name entries here. We're also going to fill in our normal type of VM stuff. That's going to be the DNS, the subnet, the gateway. We are going to use an NTP server. I would suggest to always use NTP, and then select a time zone. Now, if you are perhaps attending and you work for an MSP, some MSPs will keep all of their hardware running in the time zone for which the hardware is located. So if all the hardware is in London, we're all at GMT, 0 offset. We actually leverage the offset method here. We don't assign a time zone. We leave everything at GMT, and then we assign a time zone offset. So if you assign your offset here, you can keep the VM time in sync with your data center. However, let's say we're in London again, and we have a customer in Singapore. You can use the offset here so that Sky will display everything in your end user's local time while preserving the VM on the time for the data center it lives in London. So the VM will have London time. The Sky appliance itself will be running on Singapore time. And now we're going to select the install environment. Now this could be AWS, Hyper-V, VMware, Azure, Google, and there's even more than what's in my screenshot here. Because so many people use VMware, I've stuck with VMware for today. However, all of these principles don't apply so much for the cloud, because you're not going to have as much control over that environment. It's not like you could just walk over to Google's data center and say, hey, let me start moving these wires in this switch to see if I can improve stuff. However, for your Hyper-V, your VMware, or if you've got it, and you're actually hosting your own Oracle public cloud in your own data center, you can do all of the things that I've described to you here today. Okay, so if this is going to be a production installation, meaning you're going to start onboarding data that you need to protect and you need to be accountable for, I'm going to ask you to stop at this point. This is the point where we're going to need to get a license key. Now, just kind of an aside, earlier in this presentation, I said, go ahead and install a test VM. You can actually install 5 terabytes Sky with no license for 30 days. So if you wanted to install your Debian or your Windows with PowerShell to do some of your initial specking, do that. However, if you've got the cycles where we're going to give you Sky 5 terabytes free for 30 days, I would maybe just install that 5 terabyte Sky and I'd run some jobs. We've got some canned SLAs. We'll do a quick discovery, grab 1 or 2 things, run some backups, run some dedupes, and then use IO Analyzer to analyze the performance of this test Sky appliance. Again, 5 terabytes, 30 days, no fee. Great opportunity to kind of pre-test your environment. Okay, so now our test is over. We want a 30 terabyte pool. We're ready to go into production. We've done all of our testing. We're happy. We're convinced that everything's going to work exactly the way we want it to. In the installer pane, you can see in this left-hand picture, indicated by an arrow, this is the UUID of the VM that will be hosting Sky. Now you'll actually be able to go into the VMX config for that VM, and it's the same exact number. This is the same UUID that vSphere references the VM with. So you're going to copy that in, and you're going to send a mail out to support@actifio.com, let them know the total size of the license you need, let them know whether or not you need encryption, and then they will mail you a license key back. And when you get it back, very simply copy it and paste it here. You can see that our license field, it's got the little blurb about the evaluation license, giving you 5 terabytes for 30 days. Just paste it right on top of that. Click validate license. Make sure that you clean your input when you copy it and paste it. If you copy a space at the end, it could say that it doesn't validate. Just make sure you don't have any leading or trailing spaces. And then we're going to create an admin password. This is going to be the password that you use to log into the Sky UI. If you're using password authentication for SSH, same password. Once we create the password, we're pretty well done. We're just going to add some disks, and then we're going to be ready to go. So once you get onto the next screen, this is our storage UI for installation here. Now you can see over here on the right, those are the disks that we created earlier. That's our 10 gigabyte snap pool, our 400 gigabyte primary pool, and our 1 terabyte dedupe pool. And adding these to your Sky instance could not possibly be easier. You just simply grab it, and you can kind of see here on the bottom, and you just drag it. You just grab the SDB, SDD, SDC, whichever storage device you like, and you just drag it into the pool that you want to assign it to. We can do multiple disks into the same pool, and really it's all just a drag and drop. If for some reason you forgot to add disks, maybe you carved them out, but you didn't assign them to the VM, not a big deal. Minimize your browser, go back into VMware, get those disks attached. Maybe you needed to resize one, do anything you need to do with the storage on the back end, get it all just right, and then come back over to the installer. Up here, we can see a little refresh icon. When you hit this, we're going to make another API query to the vSphere server. And we're going to say, tell me about the disks that you see being assigned to this VM. At that point, this list over here on the right will update to reflect the disk that you've just added in vSphere. And again, you just grab your disk, drag it over where you want it, drop it. And then when we're done, we're going to click validate. That's just going to validate your storage. And that about wraps up our installation. Now, what if validate fails? Validation checks 3 things. It's going to check to make sure that you have the proper amount of memory and CPU to launch this VM. Now, it's not going to check your reservations. It's not going to check to see if you're overbooked. It's just going to say, you've given me X, and X should be enough for me to do my job. So we still need to be diligent. This unfortunately isn't going to go in and do all this performance testing to make sure we're using the right VLAN, the right interface, the right disk. This is pretty binary. Is CPU equal to or greater than X? Yes, okay, then we're validated. Now, if you chose the wrong infrastructure, maybe you're installing on VMware, but you were moving a little quick through that dropdown, you clicked AWS by mistake. We're gonna tell you we can't install the AWS because we're not connected to it. This is a VMware config. Or you didn't add the right disks. Maybe you meant to add a 400 gigabyte primary pool, and just through an error, you entered 40 instead of 400. And all of these things, we can just stop where we are. We'll tell you what's wrong. Your CPU is wrong, your memory is wrong, your disk is wrong. You're trying to install to Azure Cloud, but we're using a Hyper-V config. At that point, we can just back up, go into vSphere, fix the things that we need to complete, basically restart all of the things that you filled out in the installation will stay populated. We'll just do it again with the things set right. Just go back, change it from AWS to VMware, and then we'll click complete installation. We're going to get one reboot, and Sky will come back online, ready to go to work. And that's the entire installation of Sky. And as I said, it took me about twice as long to explain it as it actually takes to do it. Now for assessment, we've got our Sky in there, and we just really want to be diligent before we even put that first bit into a pool. We can do some just real quick checks right in the VMware UI. You don't need any command line or any sort of special expertise for this. We're going to make sure that our memory and CPU reservations were set up right for our Sky license, and we can check that under the resource allocation tab. We're going to take a look at the actual data store performance that's hosting these pools. So if we couldn't actually make our production pools earlier and we were just using those test sizes, now that Sky's up, we can use the built-in tools in VMware to get a better look at really what's going on here. If you're getting 5 to 10 millisecond read-write speed, that's okay. If you're running like an NVMe array, like a pure array, you're going to be closer to maybe 2 to 5 instead of 5 to 10. If you're running some real old, kind of worn out spinning disk, we could see 15 or 20. If we're starting to see 15 or 20, we need to be aware that we may have some performance issues. Again, we're so transactional that even those little teeny tiny overruns times 10,000 in a minute builds up real quick. And if we do find that we've got some kind of suboptimal storage, some suboptimal network, we can go back to those bulleted slides earlier and we can work through that list, and we can either identify or cure whatever's causing the contention in the resource pool to get that network asset made available, to get those storage assets made available so that we can actually do the work that we tell you we can do. Now, this next bit is going to be for tuning, and I'm also going to talk about some MSP considerations. Now, these are going to be applicable if you are going to, say, buy a Sky and put it at an MSP as a DR target, or just a replication site, maybe not DR, but in any event, you're going to pay somebody else to host your Sky appliance. Also, if you are an MSP and you are selling our solution as a service, there's a lot of things here you probably know, but I'm going to cover some of the things that generally you've got to stumble a few times and take a couple bruises to learn. So I'm going to share that with you now in hopes that you don't have to go down that same road. So a couple good, we'll call them smart practices, good tips for good performance. Now this applies in your local data center or at the MSP. However, it tends to be more prevalent that these things are not done at MSP, especially if it's an MSP that works with Actifio, if they're a partner of ours, they're probably going to know exactly what needs to be done with your Sky appliance. If you are contacting a MSP and you say, yeah, I want to host an Actifio, and they go to Actifio, what? Warning, still use them, do business with them. However, you're going to want to educate your MSP as to what this appliance really is. Otherwise, they're going to treat it like every other VM. And while it is a VM underneath, as we've just spent the better part of the last hour discussing, what's on top of that VM is anything but a regular virtual machine. This is a virtualized data agility service appliance, not just a couple of NFS shares sitting on the end of a network interface. So a couple tips to make sure that things are going to go well. We're going to want to use multiple disks on the back-end storage. We want to spin as many spindles as we can. Now, obviously, there's a point of diminishing returns. We don't necessarily want 1 gigabyte on each spindle. If it's an older, maybe a little more archaic controller that can only talk to 5 disks at once, then it doesn't make sense for us to spin 7 spindles. However, a lot of the newer controllers, stuff that came out in the last five-ish years, will handle multiple spindles at a time. So if that's the case, if that's the storage you're on, let's leverage that technology and get as many spindles spinning concurrently as possible. We're going to want to use separate RAID 6 groups for our snapshot and dedupe pools. Quite simply, so we can do our snapshot business in one RAID set, and we can do our dedupe business in the other RAID set. We don't have our snap operations waiting on dedupe transactions, and we don't have dedupe waiting for resources to be freed up from snap to continue working. Keep them on 2 completely different RAID sets. They'll both be able to run at a performance level that reflects the resources provision to the VM. Now, if this is a new implementation for you, you don't have storage picked out, you're just really getting your feet wet with Sky, this is our order of storage that we like. We will work with all of these. We'll work with DAS, we'll work with FC, iSCSI, NFS. However, if you're sitting there with a blank slate and a budget, if you can do it, NVMe, directly attached storage, is going to give you your absolute best performance. Do you need it? I'd love to say yes. The answer is no. No, you don't need it. If you're going to do test and dev and you need real high-speed agility, I would look at some of that more performance storage. If we're not going to use NVMe or SSD, I would look at 10,000 RPM spindles as opposed to 7,200. I would look at those newer controllers that can spin up a dozen spindles at a time. For data protection, you don't need that kind of agility. And we'll do agility in a data protection model. However, using DAS, using NVMe storage, I have restored a 3 terabyte SQL instance from a remote site in under 10 minutes. Yes, under 10 minutes. Now, that's probably way more than most people need. And in all honesty, the infrastructure required to do that is probably way more expensive than most people are going to want to spend. So we're still going to do all your data wherever you want it, whenever you want it, using our minimum configuration. So just to touch on disk again, it needs to be 7,200 RPM disk. Again, very highly transactional. We're reading, we're writing, we're paging. We've got all kinds of data moving around. If we're using like really old, slow spinning disk, you're going to feel it. It's going to be a performance hit that you can see reflected in your reports, and you're going to find yourself standing around looking at your watch, waiting for things to finish. If we're running 7,200 RPM disk, 10K is even better if you've got them. You will see the best performance. You will see every metric that we advertise be met. Now, no pool should ever live under multiple controllers or switches. Now, I'll unpack that a bit. What I mean is if you have a dedupe pool, that every time we want to talk to that dedupe pool, we need to pass traffic through 4 different switches to check that whole dedupe pool to find a match. Dedupe jobs are going to take days, weeks. A lot of times these interconnect switches, now that is to say the switches that sit in between these physical storage devices, in between your IBM 3700s, your NetApp E-series, they have the ability to talk to the switch that is pushing the data to them. But some of them, depending on their configuration, also have the ability to talk directly to each other. So you've spent all this money, you've got a great 10G environment, you've got the nice cards, you've got the great high speed, high throughput, high concurrency controller, and we make a query. We say, okay, we've got all this great stuff. We're going to match this dedupe object super fast. We get down to the storage at a speed of 10 gigs. The storage says, oh, I think that lives on my neighbor. It sends the traffic out over 100 megabit interconnect. Obviously, this is not what we want. We just spent all this money, all this time, all this diligence to make sure we had good, fast, high-speed storage, great 10G connections, new multi-concurrency controllers, and now we're using a 100 megabit link from 1992 to match our dedupe hash. So for that reason, let's try to keep each pool under its own controller, under its own switch. Even if it's not the fastest in the world, it's actually better to use a busier single storage array than it is to use 5 unoccupied storage arrays. Simply because when we ask the question, hey, do we have a match for this piece of data? If everything lives under one switch, one controller, we only ask the question once. If that question to be answered needs to communicate across 6 different interconnects, it's do you have it? Do you have it? Do you have it? Do you have it? Again, times 10,000, we're all of a sudden seeing some really terrible performance. When you're reserving your cores, I touched this on a little bit at the beginning. If you are able, reserve those cores across multiple sockets. Again, this comes back to bus lane contention and bus width. If we have 8 requests and we can only make 4 at a time, then we need to make 2 requests of 4 things. But if we split this across 4 sockets, then we make single requests for 2 items to all 4 sockets. And we don't end up with any queuing. All of our requests get serviced immediately. A couple more considerations, and this is a little more MSP oriented. Again, revisiting back on how important it is to make sure that your pools are correctly configured under the right controllers and the right type of network infrastructure. Again, you should not have a pool that we need to talk to 4 switches to access. So spreading pools across multiple controllers will underperform. And it's for that reason I mentioned, instead of asking the question, do you have a match for this, one time, we ask it 6 times. Now, you're going to see the performance hit here just in a regular dedupe job, where this is really going, and you might see it and say, oh, well, Dave, it's a little slow, but we got a great deal and we can live with it. Okay, let's run a GC and a sweep. That GC and sweep on a deployment where our dedupe pool is sitting in 5 different storage cabinets is going to take you almost 90 days. Nobody has 90 days for GC. As many of you have maybe encountered, and if you're new to Actifio, I would like to let you know that when we're running a GC or a sweep, we will actually lock the dedupe file system from accepting any more full ingest. So if you want to run incremental jobs against data we've already seen before, apps and hosts that we've already discovered, those will continue to run at a degraded performance rate because that disk pool is busy with the GC and sweep. However, if you needed to onboard a new app or a new host, protect a new vCenter, those jobs will not complete until the GC and sweep is done. Now we get back to our 30, 60, 90-day GC and sweep. Nobody here, myself included, has the kind of wiggle room to delay protection data for an entire quarter. Generally, we get new data, we need to protect it in the first 24 or 48 hours. We definitely cannot wait 90 days. So even if you set it up and it's not great and you think you can live with it, just dump some data into that dedupe pool before it gets important and run a GC and sweep and see how long it's going to take you. The last thing you want is to have been ingesting data for a month, things are going well, your incrementals are good, your dedupe ratios are starting to level out, starting to get some good value, some good dedupe, and then you've got to run a GC, and now you can't ingest any more apps for a month or 2 or 3. So if you're not sure, like I said, if you're on that fence to Dave, the performance kind of stinks, but I think we can live with it, just give it arbitrary data just to get that dedupe pool filled up and then run a GC and sweep, see how long it takes. You may be able to live with the prolonged job runtime, but that potential multi-month GC and sweep is probably something you can't live with. And it's obviously better to find that out in the first week than it is to find out a month down the road. And even bigger issue there, if you needed to restore from that, the restore would take forever. So we would have to go to all 5 of these storage cabinets, find all these 4K chunks, reassemble them. We've got to ask the question 10,000 times a minute times 5 different controllers. You are most certainly not going to hit your RPO or RTO in that model. So again, when you're setting these things up, just go ahead and test them. Again, 5 terabytes, 30 days, no fee. Go ahead and fill the dedupe pool. Doesn't matter what you put there, and just run the GC and sweep. Make sure everything's going to run the way that you expect so we can identify any issues before you actually go into production. We can engage our support, our services team. We'll get in there, we'll get everything really working right. And even if things are looking pretty good, but it's, Dave, things aren't working and I don't understand why. And we go in and fix, okay, well now Dave, things are working great and I don't understand why. Go ahead and give us a call. Let us know what you've got. We can access them via WebEx or via our Secure Connect client. And we can take a look and we can kind of explain it to you to enable you to do this successfully going forward. Now, if you really want to go fast, and this is actually a requirement, if you have a bigger than 30 terabyte dedupe pool, you're going to want to put SSDs into your vSphere environment and assign them to your Sky appliance. These SSDs will be used by our dedupe pool as a cache. Specifically, it is a ZIL, Z-I-L. Now that's ZFS intent library or ZFS ingest library, depending on which school you come from, I guess. Now what this will do is all this page caching that I was talking about earlier when we were talking about memory reservation, we'll send that off to the SSD if we do have to cache. Now, obviously, this NVMe storage that we see made available to us today is much, much faster than the spinning disk storage. It's generally more accessible than adding memory. Generally, these nodes are pretty well maxed out. Enterprise memory is expensive, and it's not always a great solution to just continue to add memory. However, a couple of SSDs at enterprise level is a relatively inexpensive investment. And if the performance means that much to you, or if you have a dedupe pool of 30 terabytes or larger, you're really going to want to get these SSDs added. It is a tangible difference in performance. It'll feel like somebody gave you a brand new product once you add these SSDs. And again, this just comes back to There is some kind of special Actifio stuff that goes on with the dedupe engine, but really underneath it all this is page caching. So everything that you learned in your comp sci classes, everything that you've learned in your careers about page caching, it applies here. Hence the need or want for SSDs in skies under 30 terabytes and need for SSDs in skies above 30 terabytes. Now, if you are kind of new to this, data management can be a bit of a tricky business until you get your sea legs. I would recommend always leaving a couple of unassigned disks until you've really got a firm hold on your environment, your deployment. And so what these will do is, let's say you have overconsumed your Snap, you had to onboard some new apps, the boss gave you a whole rec list, so we need to protect these 4 racks out in the data center, and maybe you missized it a little bit, or maybe the SQL DBA who was supposed to give you the size of the database gave you old information or left a digit out. Now you've completely, because of this kind of clerical error, we've completely filled our Snap pool, and now we need to restore from dedupe. Well, if there's no room in Snap, we don't have any place to build that restored dedupe image. And this is why I would leave 1 or 2 disks sitting unassigned, but zoned in and made available to the Sky appliance. If we get into this kind of a foible where we've unintentionally filled our snapshot pool, we can just add these disks in, we can get our restore done, and we can reevaluate our storage needs after. However, when you're in that moment, it's, and it always happens, 4:45, Friday afternoon, great plans for the weekend, and oh no, the Oracle admin did not do a local backup, and he's just completely trashed his rack instance, and he needs a restore. Rather than scrambling around trying to find some disk, run down to the data center, get the disk into the shelf, get it zoned in, get everything done, make sure your firmware matches, just get it in there ahead of time. The price of 2 hard disks is pretty negligible. And while you're kind of going through this little bit of a learning curve, if you're transitioning from a product like a backup exec or a Veeam where things work a little bit different, I always just advocate for just leaving a couple extra resources there while you're going through that learning curve, just to make sure that you're safe. Hopefully you'll never ever need to use them, but at that, the Oracle DBA who needs his rack admin restored at 5:45 on a Friday afternoon, those 2 disks are going to feel very, very inexpensive when all you've got to do is add those 2 disks to the snapshot pool, and then you're off for your great weekend's plans. The restore is running, plenty of room to bring it back, and everybody's happy and in good shape. Again, for the price of 2 physical disks, it almost seems silly not to. Now that we've got everything, we've tested it, we made sure we're in the right environment, we've troubleshot our issues, we've done some tuning, we've really made sure that everything is going to work great, exactly how we want it. How do we maintain? So we've got things like the report manager, which Paul Martel did a great webinar on. You can see that at our YouTube channel. We also have insight reports. Now, these insight reports are an opt-in weekly PDF mailing. Or if you log into your portal account, you can see the kind of, looks like a solar system map that says Get Insight. That's right on the front page of your portal. Right when you log in, go about 1/3 of the way down the page and you'll see that bright blue icon there. These reports are some of the most useful reports that we can get for forecasting and planning. Now here's some examples from a test cluster. Now on the top right, if you have a highly consumed Snap or dedupe pool and you're not really sure why, take a look at your insight report. The insight report will tell you the top pool consumers by app and by host. So if you've got, we'll go back to the SQL instance that was misreported. You expected it to be 100 gigabytes. Turns out it's 1024. It's actually a terabyte. That will sit right at the top of this list. So if you've got your own audit of how much space these SQL instances need, you can use this list to see how many gigabytes or terabytes they're actually using on disk in the Actifio system. It's a good way to kind of plan for expansion. It's a good way to just a sanity check to make sure that we are ingesting what you think we're ingesting. If you see a spike here, that could let you know that maybe we saw a database reindex. A machine had to be completely restored and all the data had to be rebuilt, and it basically was a new ingest. Now over here on the left, that orange line is my dedupe pool, and that blue line is my Snap pool. So what I've done here is I've actually just filled a dedupe pool with data that cannot be deduped or compressed. So as we can see, it keeps growing. And I did this for a purpose. So we can see each one of these vertical lines represents 30 days. So in 30 days, our dedupe pool went up about 20 terabytes. Now I've looked at hundreds of these reports over the years, and I can consistently tell you exactly when that pool is going to fill. I can get it right down to the week. And so can you. If we were to take a ruler and lay it down on the beginning and end point of this plotted line on this graph, it's going to intersect at a date down the road. Now I can tell you in this case, this cluster will be completely full by the second week of April. And that's okay, because we've looked at it in the third week of March. We've still got 3 weeks to add disk. We're not in trouble. We're okay. So I would really, like I said, these come out weekly. I'd look at them once a week because you'll see patterns like this. You'll see trends. And it lets you know that you are pushing enough work to get all the value out of the appliance, but not pushing so much that it's going to cause problems. I'll show you that here. So on the left, we've got a slightly longer pool history here. And as we can see, we're using a lot of space, but am I worried? No, I'm not worried. Why am I not worried? Because I can track the storage trend. We can see that beautiful sawtooth pattern. We see applications come in, they hit their 1 week retention, and then they get expired out. And on the dedupe side, we see data come in, those little spikes that you see, that's the moments before a GC and a sweep runs. And you see the back side of that slope where it drops down. It almost looks like an EKG pattern. That is after the GC and sweep runs. Now, the reason it doesn't drop straight down and it kind of comes off as an angle is because you'll actually reclaim space as sweep is running. You reclaim most of the space that you're going to get in the first 50%. We don't make you wait until sweep is 100% done and then just give you it all back in one package. We'll give you back gigabytes at a time as we're going through and cleaning things up. But using this chart on the left, I can kind of, again, just drop a ruler across those peaks. And the last report here is March 1st. I happen to know how big this pool is. This pool is going to be full on about April 8th. Now, wouldn't it be great when you're doing your budgets for the quarter, you're doing your forecasting, storage expansion, if you could walk in to your manager and say, I'm okay until April 1st. However, sometime in the next 8 days, the system is going to reach 100% consumption and we need to get disk. Let's get that disk today. Let's never let it get to that point. And using these insight reports, you can get a very accurate, accountable storage consumption trend so that you're able to proactively add storage, add space, make the adjustments needed. Maybe you have two skies. One's doing 90% of the work, the other one's doing 10. Maybe you don't need any storage. We can just migrate some apps and kind of balance them out. Another way we can check that is we'll take a look at the picture on the right here. Ensure Sky is processing enough jobs and track you for expansion. Now, what we're seeing here is slot consumption. Now, each job, snap, dedupe, remote dedupe, even expirations, all require one job slot. We can do about 16 things at once, as you can see by that purple line on the top. And I love this report. As we can see, these spikes are almost touching that 16, but then they dive right back down. That tells me that we've got this particular Sky instance tuned about perfectly. It's using, you're getting every dollar that you spent. We're using 95% of the available compute and slot resources, but we're not exceeding it. You're not hitting errors, you're not hitting failures, you're not ending up with jobs and extended queue times. We've really got this dialed in, absolutely perfect, and you're getting every penny of your investment out of this. If we looked at this and everything was down around 5 or 6, absolutely, let's put more data on there. Now, if it was pinned, if it was just a flat orange line that ran parallel across that 16 bar up here at the top, then obviously we're overconsumed. We're going to want to add another Sky. And now this comes into kind of our different Sky use cases. In some cases, the data warehouse kind of model makes sense. Let's put a huge pool behind a single Sky instance. Data protection is the perfect example of this kind of use case. And we're just going to send all of our data at that huge Sky pool. And let's say we've got 50 users. Great, 50 users all using the same Sky pool. Everything's protected. Everything's wonderful. If you wanted something that was maybe more agile than you could really get out of a data protection model, what might make sense for you is instead of buying one Sky at 50 terabytes, buy 10 Skies at 5 terabytes or 5 Skies at 10. 5 Skies at 10 terabytes, now you've only got 5 users using each one. And so when you look at these charts, in the insight report, if you're really pinned out, maybe the answer is not add storage. If your storage consumption is looking okay, but you're running out of slots, what we really need is another Sky appliance to add another 16 slots worth of job throughput there. And again, in the past, and I've been working in this space for well over a decade, the data warehouse model is prevalent. Let's get a single piece of storage or a single cluster of storage and just add and add and add and add and add. That's not necessarily the right answer anymore. The industry has changed, the way that we use data, the way that we serve data. All these things are different. And with a virtual appliance, Sky doesn't take any room in the rack. We don't have to worry about whether we've got the cooling for it. We don't have to worry about drops for electrical power. All we need to do is carve out a VM. And so because of that, we don't have some of the drawbacks. If you were to put 10 CDSs in, you would need 30U worth of space, all kinds of wiring, all kinds of redundant power. You would really need to check with the HVAC people to make sure that you had the proper cooling. With Sky, we take 0U. You might need to add a compute node if you're putting a lot of Skies in there. Okay, so maybe 2U if you really need to beef up your virtual environment. But now we can make these smaller, less expensive, more agile Skies available to multiple users, rather than just putting this one monolithic entity into the data center that everybody uses. We can really deploy these, and MDL is what we really care about. We don't really care, whether it's 5, 10 terabyte Skies or 150 terabyte Sky, that's still 50 terabytes of MDL, no matter how you slice it. So if it works better for you and your users to run 5, 10 terabyte Skies, consider that solution. Try to break away from that kind of data warehouse mindset that has been around for decades. That single monolithic one piece of storage that everybody accesses is no longer the right solution. And with Sky, with the different offerings, with dedupe, without dedupe, database only, 5 terabytes, 1 terabyte, 50 terabytes, you can really custom your solution to exactly what those users want. And again, the MDL doesn't change. It's the exact same MDL, whether you're using 5 really agile ones or 1 big monolithic one, the numbers stay the same. As I said before, if you're just installing Sky, my capacity planning webinar is really the absolute best place to start. You can see that over at YouTube, Actifio Enablement Team. This is an active link. I will be sending you this deck when we're complete here. Every link that's in here, to include the link for the IO analyzer for VMware, they all work, so you can just click through, get all the tools you need, and start digging in to see what the right way to deploy is. So we did run a bit long. I do apologize, but I do appreciate you sticking with me today. Anybody here who's come in and joined Paul for some of the instructor-led training, if you're using a Sky, you're actually using a Sky that has been built from a snapshot. But again, once you have production data on Sky, you don't want to snapshot it and try to restore it. It needs to be persistent at that point. But these 5 terabyte free Skies that I'm telling you about that are free for 30 days are great accessories to have with our free Sky e-learning, our free e-learning on SLA creation. We've got a ton of great content that Paul has put together. Take advantage of this free 5 terabyte Sky so you've got yourself a free lab system. You can go through all of our stuff. You can join Paul in an instructor-led training. You can get into our knowledge base. We've got tons of great webinars. We've got some free e-learnings. You could use that Sky to follow along with what's being taught. But I would really encourage everybody here to take advantage of this, we'll call it a consequence-free, free 5 terabyte Sky.
Okay, that looks like the end of things. Thank you very much for participating once again. And thank you again, David.
Thank you, Paul. And everybody, you should have received an email today regarding our RTO webinar next week. And 2 weeks after that, we will be doing Actifio Daily Administration in just 10 minutes a day. Make sure you take a look at those and get signed up if those are topics that interest you. Thanks again for joining, everyone. Thank you for joining us for another YouTube Tech Tip video. If you like the content you're seeing on this channel, please remember to like the video, subscribe to the channel, and turn on notifications so you will be alerted to any future content.